Hey, I'm Mike and welcome to Eat It Make It. So if you're like me, you like to do as much as you can yourself. It can be challenging, but also pretty rewarding, at least when it works out. And sometimes it can be very, very time consuming. Well, we don't need to do everything ourselves these days because there are some other options. And I actually wanted to see how good those options really are. So in this video, we're going to take a whole bunch of custom parts, send them away to have them made, and then we're going to take a very close look at them to see how good they really are and if they can actually do the job they're supposed to do. So stick around. An opportunity came up to work with PCBWay, and if you don't already know, they do a lot more than PCBs. They can CNC machine custom parts. They can 3D print just about anything you can dream up in plastics and in metals, and they have access to the latest tech, so they can do it quickly and at a reasonable price. Now, rather than say this video is sponsored by such and such, I thought it would be much better to design some fairly complex parts and have them manufactured by PCBWay to see just how good they really are and how precise they are. These are going to be parts that would take me days to try and make myself or would be nearly impossible to make in my home shop. And I also want to see if using a company like this can open up some possibilities for us to be able to come up with an idea, 3D print it ourselves, tweak the design at home, and then send it away to have it made from metal or 3D printed using SLS or MJF for a long-lasting, high-quality part, maybe even to sell. So this video is not sponsored, but I didn't pay for these parts either. So if the parts are good, I want you to see for yourself. If they're not good, I also want you to see that. So let's get into it. So I whipped up a whole bunch of parts and ordered them through their website. There are a lot of options for materials, so I stuck to mainly choosing material that was best suited for the job. That is, except for one, because I saw it and I just wanted it. So 3 weeks has passed. Let's go ahead and open everything up. So I resisted the temptation and I have only opened one package. I'm sorry, but I just couldn't wait. But I do want to leave this one to the end because this is pretty cool. Well, I think it's pretty cool anyways, so. But you guys will have to let me know what you think about this one when we open it up. Let's open up the rest of them. So these look really good. We will also take some measurements, but most importantly, they just have to fit correctly into the mating part. So we will check that a little bit later on. Oh, look at that. Wow. Very nice. So this is a little custom wrench, and this specifically fits my lathe or South Bend lathes of the same time frame. And I've got all the little details, including the model number on there as well. So this is just meant to be a reproduction because you can't really come by these anymore. But I thought it'd be kind of cool to try and reproduce one. So it is 3D printed from tool steel. Pretty cool. I like that. So here is the original, and then here is the new version. Now there is a little bit of a difference, and that is because I found that I could make it a little bit beefier. Also very nice, gorgeous part. This may be the nicest part on the lathe. Oh yeah. So this is nylon. Oh, look at that. You can see my little logo there. And I wanted this to be plastic mainly because I thought it was a good idea from a friction standpoint and to prevent any wear on the lead screw as well. So I think the plastic is probably going to be the best solution. There's no need for it to be made of metal. There's very little load that gets applied to this. So another nice part. Pretty cool. This must be the dial face. Oh, it is. Yeah, look at that. And the idea is just to spray paint this and then sand the surface smooth. Quality looks good. We will have to put all these pieces together a little bit later on to find out if everything does fit. Again, this is another part that is pretty much obsolete. It's very difficult to find these, and I did add this in. I actually really wanted both it to say South Bend Lathe Works, but also to see what kind of detail could be captured with an aluminum part. And here you can just barely see these little ridges that are added in a circular formation. I added those because the original has those as well. Top notch. I want to actually try this out a little bit later on as well. Make sure this fits properly because the original one was fairly worn in here and I've tightened this up a bit. Oh, nice. I have never held a piece of titanium. There is no good reason to have this made from titanium aside from just wanting to see what titanium looks like and what it feels like. And it's fairly light. It looks good. So this is supposed to fit into here. Ooh, look at look at that. Let's see if this one fits. Oh, I think this one's going to fit too. Oh my God. So there is one more piece to this. Let's unwrap that one. Oh, cool. That looks really neat. So all of this goes inside of here. Right now, it all looks really impressive, but I do actually want to try everything. So let's go ahead and move on to the next step. We're going to see if these parts actually fit and do the job they're supposed to do. Well, before we can test these parts, I need to do something about this lathe because it is absolutely disgusting. So what I'm going to do is take it apart. I'm going to clean all the parts. I'm going to degrease them. I'm going to strip all the paint. I'm going to tape them up. I'm going to prime them. And I am going to paint them. And then I can get it all back together. And here we have the finished lathe. All put back together. It's all working properly. There's a few little things I want to take care of. This faceplate needs to be replaced. It's just a little bit too worn. And this belt is going to be replaced with a timing belt. It's on order. Unfortunately, it did not make it here in time for this video. So I think now it is a good time to get some of those parts that I designed and then ordered from PCBWay onto this machine. So first up, I have these brass jaws that I designed for the follow rest, and I restored it the same way that I restored the lathe. This is what the original one looked like, and it only came with one of them. So I changed the length of it because I think it's going to suit the rods that I want to put into this lathe a little bit better. This one was shorter and made from steel. These, of course, are made from brass as well. As pretty as these are, what is most important is that these are accurate. So I have a requirement for 11 millimeters in the thickness. We have 10.96. In the width, I have 22.2. Ooh, look at that, 22.19. So let's go ahead and get these on and see if they actually work. So here is the follow rest. Let's go ahead and mount this on the lathe. So as I move the carriage along, the follow rest does exactly what it's supposed to. It follows along. The next fairly simple install is the lathe thread dowel. This made its first appearance in a previous video, and this is made from ABS glass fiber reinforced. And if you haven't seen that video, I'll put a link up above there. Now, some of you mentioned in the comments that you didn't like the fact that I used glass fiber when it was touching anything steel, it could wear it down. So I have listened to you and I've made some improvements. And this new gear is made from nylon. This is multi-jet fusion. We do need to tap a little hole there. That's going to be a 1/4 to receive a set screw. Other than that, overall quality looks really good. The function is good. It shouldn't wear down the lead screw. And I haven't tried painting this. This is nylon, so I probably need to prime it with something special. I'm going to leave it like this just for now. There's only one critical area for dimension, and it's not even that important. This should be somewhere around 9.6, 9.61, very close. And mine, 9.7. So the multi-jet fusion really doesn't show layer lines. It has a very uniform texture on all sides. And the other parts were printed from nylon glass fiber, and it is very stiff. Actually doesn't feel like plastic at all. And you can see the very slightest sign of layer lines. This was printed kind of like this at an angle. You see these lines? very faint. Can't really feel them. So you can buy the original cast iron, and it's just a standard straight cut gear for about $200 on eBay. And they don't actually look this good either. So this as a kit is something that's kind of sellable. It looks really good, it's professional, and it should work. Let's go ahead and tap these holes. So here's the one that I made. Works well, and you just disengage it by tilting it forward. Pretty easy. Let's go ahead and install this one. The thumb screw position is quite a bit better. Actually, I might want to rotate it down a little bit more, but that's good. So you can position it, lock it, nice. Yeah, that works great. So you can see after loosening the screw off just a tad, it wants to lean away from the lead screw, which is good. Next up, we have this 3D printed aluminum. And as far as what is accurate on this part, really only this area needs to be accurate, and it doesn't need to be that accurate. It needs to be 20.1, which is larger than it needs to be, and it's a little bit undersized, 19.87, 19.88. Now I added this text because I wanted to see what the aluminum did, and if we compare that to the steel to me looks far more crisp than the aluminum version does. The aluminum doesn't look too bad, but the steel really looks good. So here is the original. And it's a little bit loose on the nut, but it doesn't seem to cause any problems. Let's try the new version. Oh, look at that. The new version is just a little bit too small. So that will require just the smallest amount of filing. Let me do that right now and I'll come right back. All right, so after about 10 minutes or so of filing, I've got the entire inside filed. Let's see how it fits. A nice fit. Okay, so now I want to try one more thing with this part. So I'm going to use a Scotch-Brite pad to see if this can polish up just like a regular piece of aluminum. That polished up beautifully, and I spent probably 10 minutes getting to this point. Really not that much, and I just have a generic Scotch-Brite pad. I'm sure you could take this to a mirror finish if you wanted to. This looks really good. And again, the original. Next up, we have this tool steel 3D printed open end wrench. So I designed a replica of the original. And the steel version really captured the details well. Quite a bit better than the aluminum version. You can see the embossed area, the raised text in here, and everything in here as well. Dimensionally, it should be 9.5, 9.75. So there is a little bit of an issue in here. These faces should have been 90 degrees to each other. You can see that they're slightly flared out. It looks more like the original, where there's a bit of wear, but I did not put that in the design. So that's something to be aware of. On the inside here, it's a little bit too small, and on the outside, it's a little bit too big. The original is 65.92, 67.39. So that seems like it is a completely solid part. There are no inclusions in here. There are no very tiny air pockets through the 3D printing process. This is actually heavier than the original. So let's take a look at how this files. It should be fileable. And I have a diamond stone here. And you can see after about a minute or so, it is pretty flat, not perfectly flat. I'm going to also buff this one just like the last one. Look at that. Absolutely beautiful. So this was originally used for tightening and loosening the lantern style tool post that went up here, and I still have it, but I don't use it. But there are still some machine screws with a square head on them. This is the open end. Closed end. Yep, still works, no problems. Now this is the part that caused me to want to make this video in the first place. Now my intention was always to have one CNC machine made, but it's a really good idea to take some time and 3D print what it is exactly that you're looking for first. And in fact, I've made some improvements as well. There is a little oil hole. The original does not have the oil hole. I've also confirmed that the threads fit perfectly. I was able to make the new version much larger as well, both in the width and in the height. This one here extended quite a bit further down, and there was no reason for that. This is supposed to be 17.42. 17.39, very close. The height here isn't critical, 18.61 I believe it was. So now we have a bit of a problem here. This is not threaded on the inside. And that's kind of important for this particular job. And the reason for that is because this thread that I need is a non-standard thread size. It's Acme, and it's also a left-hand thread. So when I submitted it, they said yes, they could do it. But after reviewing it in more detail, they said that they would have to order special tooling to get this job done. And that didn't make a lot of sense. So I ordered this. This is a special size tap, and this was only 20 some odd dollars off of Amazon. And this should do the job, and actually I want to have one of these because I want to try and make one of these myself later on. Well, I would absolutely love to finish this off in this video, but it's going to take me quite a bit of time because I don't have all the equipment that's necessary to make sure that I'm holding this part and this part in perfect alignment when I start to thread this. So I'm going to take a bit of time off camera after the video and get this to work. Now it is completely up to my skill level whether I can actually get this to work on the lathe. But what we can do right now is make sure that this fits into the cross slide. So that was a nice slip fit. Now this system works by having the set screw you tighten down. It's tapered on the bottom and it pushes against this little steel piece that pushes against the side of the hole to lock everything in place. Last one. Let's open this up. And I'll tell you a little bit about this, what it's for, and what we did to make it. So I already opened this because I just couldn't wait, but this, my friends, is a custom Collet Chuck for the lathe. And these are available. They're about $200 for a set, and they're quite long. They have a lot of stick out. This one is designed to be very stout. It's going to be extremely sturdy. And I've got these 3 points on here which are drilled in so you can tighten or loosen. And it takes standard ER32 collets. Like so. This may look pretty simple, but there's a lot going on here. So we have some threads that need to fit perfectly with this. Inside there is a taper that also needs to fit perfectly, and that is extremely important. And then on the inside, there's a thread relief at the very bottom. These threads are supposed to fit the spindle. And then here we have this little relief cut here, which wraps around the spindle for a perfect alignment. All right, so the beauty of one of these designed this way is that there is a pass-through completely through. So you can start with long stock and it can go all the way through the headstock. So that was a 3/4, and you can go down to, well, really any size. This is 1/8 of an inch that fits in here as well. So there's a lot of options, and you can put tooling in here, you can put stock in here, and you can see how short this is. There's going to be very little stick out. And I designed it to use these guys in these holes in order to tighten it down, and they fit perfectly. All right, let's see if we can get this thing on here. Okay, so there is a problem. Let me take a measurement, see what's going on here. Okay, well, I screwed up. I wanted this to seat perfectly on this flat section of the spindle, and I did not think about measuring the threads just outside of that. And the threads outside of that are slightly larger in diameter. So here we have 38.16, and here we have 38 millimeters. So I sized the inner bore to 38 millimeters, and I was thinking, well, that would seat absolutely perfect on there, when in fact the threads should have been a little bit deeper. So unfortunately, I'm not going to be able to mount this on here today, but I should be able to make this part work. I can put it into the 4-jaw chuck and then very carefully machine out the threaded section to provide a little bit more depth in the threads, just a very, very minute amount in order to make this work. I already went ahead and checked to make sure the thread pitch is correct, and it is correct. So the only issue is the amount of clearance that is left in here. So not a big problem, and it is definitely something that I can fix by using the lathe. Overall, a very impressive part. I'm extremely happy with how this turned out. Well, I couldn't just leave it there. I have a problem. So I spent a little bit of time refining these threads in here, and also just boring out this shouldered area just a tiny little bit, because it was a little bit undersized, and I'm pretty much there. I have the back gears locked just so I can tighten this up. Seems to be running pretty true as well. So maybe not my best work ever, in the fact that I didn't do a good enough job in the design phase for this, but I can always go ahead and redo it with the correct threads on the inside. The metric threads on the outside work perfectly. This is the bore, the angle, everything else is absolutely perfect. Just the way that it fits on the spindle needed a little bit more attention, but I'm pretty happy with it now. So this is the first time I've ordered anything through PCBWay, and when I use them again, there are a few important things I need to keep in mind. Some of the parts take a couple days to produce, some of them take up to 2 weeks to produce. So I'd expect to wait about 3 weeks from the time of order to delivery, and that's probably going to vary depending on where you live. Since I had lots of fine detail, PCBWay sent me an email to let me know that some of the details were actually too fine to capture. Since this was a test, I wanted to see if they were actually capable of it. And after looking at the parts, I actually thought the amount of detail was pretty good. It was better on the stainless steel than it was on the aluminum. So if I were to do the aluminum again, I would increase the font size. We can also expect a small amount of shrinkage and or deformation of the 3D printed metal part. So if I were to order the wrench again, I would have compensated for that on the open end of the stainless steel wrench. And lastly, the Collet Chuck was a last-minute design request. I had an idea, I whipped up the model in less than an hour, and I ordered it from Tool Steel. I thought it would be a cool part to show off in this video. I also wanted to challenge PCBWay with something that's really complicated. And if I had a bit more experience with threads and clearances in steel, it would have saved me about an hour of adjusting the internal threads. I don't have any regrets about it because I've learned a lot in this process, but it probably would have been better to take a bit more time to adjust the clearances and the threads before I sent it away. So if I had ordered all the parts at the same time, the total would have come to $426, including shipping. But because I had a last minute request, it shipped in 2 packages. So it is best to combine everything into one order, and you can save on shipping. I will leave a breakdown in the description there below on how much each part cost if you are curious. I guess you can probably tell from the video that I was pretty happy with the results, but here is what it really means for me. I can take an idea, I can 3D print it at home, and I can fine tune it to get exactly what I want. And if I need to get it made from metal or something to be a bit more industrial, I have an option to make something that is more of a permanent solution using PCBWay. Sometimes 3D printing at home just won't work because the parts aren't going to be strong enough. So there is another option where you can prototype at home and then have a long-term solution made. If you like this type of content, I'd love it if you were to subscribe. It helps to support this channel. I'm committed to making quality content that's always new. And if you want to see even more content like this or other parts being tested, please let me know. Thank you to each of my patrons for helping to support this channel and making videos like this possible. And if you want to help support this channel as well, there is a link down there below. I hope you enjoyed the video and found it helpful. Take care, everybody. We will see you on the next one.